Yes, I have started the recording. You can write your roll numbers in the chat box. Right. So I guess in the last lecture we have discussed about cross product, right? So cross product definition and all that. And once one of the example based on dot product and cross product we have started discussing, right? So what was that example? Can someone tell me? So the example was is like if just a minute. If a bar is equal to 3 a bar x, a bar is equal to 3 a bar x plus 4 a bar y, 4 a bar y plus a bar z, a bar z, and b bar is equal to 2 a bar y, sorry, 2 a bar y, 2 a bar y minus 5 a bar z, minus 5 a bar z, right? So two vectors are given, and what they are asking is to find the angle between a bar and b bar, right? So this is what they have asked. Find angle. Am I audible? Hello.
Yes, sir.
Okay. Find the angle between a bar and b bar, right? So this they have said that you have to find out in two ways. Number one, by using dot product, which we have done in last lecture, right? So this thing we have solved. And what was the answer? What was the answer for that? Theta is equal to what answer we have obtained? It's 83.73, right? 83.73. So this was the answer that we have obtained in last lecture for dot product. Now second part of this example is to find this angle between a bar and b bar using cross product, right? So for cross product in last lecture we have written two definitions. So I'm going to write those two definitions over here. So what are those two definitions? For cross product, I should say here a bar cross b bar, a bar cross b bar is equal to ab sine theta a bar n. This is one. And second definition of a bar cross b bar is equal to determinant of a bar x in the first row, a bar y, a bar z, right? In the second row, ax, bx, cx. Sorry, this has to be ax, ay, az, right? And here bx, by, bz. right? So this is a second definition of cross product, where two vectors are a bar and b bar. A bar cross b bar is equal to ab sine theta a bar n is the first definition, and a bar cross b bar is equal to determinant of ax, a bar x, a bar y, a bar z, ax, ay, az, and bx, by, bz. So this determinant is basically a second definition of this cross product, right? Now let us use the second definition and let us try to find out the value of a bar cross b bar, right? So to obtain this a bar cross b bar, I can put up the values because we have those two vectors here. So from equation 2, or let's say this is definition 2 or equation 2, this one, this is as 1, this is 1, this is 2, right? So from equation 2, we can write a bar cross b bar, is equal to determinant a bar x, a bar y, a bar z. This is in first row. Second row, ax, what is the value? Just observe the vector mentioned there, a bar, and from that tell me the coefficient ax. Ax is nothing but 3, right? Then you find out ay. So you will find this ay here. This is your ay coefficient, right? So ay is 4. Then az is 1. Similarly, for vector b bar, identify all the coefficients. Bx is 0. Bx term is absent, right? So that's why this coefficient is 0. Then next, by is 2. By is 2 and bz is -5. So I hope you understand how we have written this determinant in this pattern as per the definition, right? So this way you can write the determinant, and now we can proceed to solve this determinant. If you could do this rough work, you will find it is to be equal to -22 a bar x, -22 a bar x plus 15 a bar y plus 6 a bar z. Can someone check and tell me whether it is correct or wrong? 6 a bar z. Solve this determinant and tell me whether it is correct or wrong. -22 a bar x plus 15 a bar y plus 6 a bar z. Are you able to solve the determinant? Are you getting this answer? Can you hear me? Am I audible? See, until you tell me this, answer of this determinant is this one, we will not proceed further. Shivani Arekar, Vaishnavi Walke, Sonali Katte. Can you?
Yes, sir, got the answer.
Okay. Have you checked determinant? Have you solved the determinant? What answer you are getting?
Yes, sir, -22 a bar x plus 15 a bar y plus 6 is a bar z.
A bar z, correct. Shefali Gaddam, What answer you are getting? Shefali Gaddam.
Yes, sir.
You are getting that answer? Have you solved determinant? Prajakta Kamble. Prajakta Kamble, are you there in the meeting? Minal Mamane. Prajakta Kamble, Minal Mamane, are you there in the meeting?
Yes, sir.
Are you getting that answer or not? I have solved it on the screen. Determinant was given. Onkar Madgya. See, if you are just attending the classes just to kind of like your attendance and all that, you please don't attend. I will mark your presentee. Just we are asking you to attend. That's why you are attending. It means nothing. I'm just asking you, and I don't think it's a difficult task. What I asked is whether the determinant which is written over here, this one, for this determinant, are you getting this answer or not? So I'm not asking like anything any rocket science. So from class of, let's say, how many are attending? 37. Out of 37, only hardly 1 or 2 students are saying, sir, yes, it's correct. And others, they are not able to even turn on the mic. I don't understand what is the problem. Let it be. Once again, I repeat, if you are attending the class just for sake of attendance, please don't do that. I will mark your attendance. I will mark you as present. You please don't attend the classes. Right. So this way you will get actual cross product. A bar cross B bar is equal to this one, right? Now we have to use the second definition, and the second definition, how will you use the second definition now? See, second definition is A bar cross B bar, okay, is equal to AB sin theta A bar n. Now actually this vector, any vector, we can write it as, for this case I'm writing it for sin theta, right? So for sin theta, I'm just keeping see this equation number 1, right? In equation number 1, we have on a both side we have a direction, right? Means you are having a direction on this side as well as on this side. So equation 1 I can write in terms of magnitude only. See, let's see how I can do that. Equation 1 can be written in terms of magnitude only. So on left hand side of equation 1, I can write A bar mod of A bar cross B bar. That means I am taking only magnitude of left hand side. It is equal to. On right hand side also we are taking only a magnitude, right? So in that case, what I can write here, AB sin theta. This is the only magnitude, right? A bar n is the direction, but I do not want to write the direction here. So equation 1 is rewritten in terms of magnitude only. So this is nothing but equation 1 in terms of magnitude only, right? This is in terms of magnitude only. Now can someone tell me next what would be the next step to find out theta?
So we have to find the magnitude of that minus 22 a bar x, that equation.
Correct.
And then we have to put the values in that last equation,
Okay.
and we will get the value of theta.
Yeah. So this equation we have obtained. So simply what I can write here, sine theta is equal to mod of a bar cross b bar mod of a bar cross b bar divided by AB. AB is nothing but the magnitude which I guess we have calculated yesterday. So here mod of a bar cross b bar means what? Magnitude of this one. Magnitude of this one means this is under root. This is under root minus 22 bracket square plus 15 square plus 6 square, right? Divided by, yesterday we have calculated this a. What was the value of a? It is under root 26. And what is the value of b? It is
29.
29. Correct. So do the calculation on calculator and tell me the value of sine theta. Value of sine theta must be 0.994. This is the value of sine theta. So value of sine theta, if it is 0.994, in that case, what is the value of theta? What is the value of theta? Therefore, value of theta is equal to, can anyone tell?
85.24.
Can you calculate once again? It has to be 83.
83.72.
83.73, right? So we have obtained value of theta for this case also. So I can write here by using cross product. Just now we have solved. What is the value of theta? Value of theta is 83.73. So what is the conclusion from this? What is the conclusion from this? See, if two vectors are given, while solving for the angle between those two vectors, let it be using dot product or by using cross product. The answer of theta would be same. So the angle between those two vectors will not change. Getting my point? Because those two vectors are stable and they are pointing towards some direction, and you are finding the theta. It doesn't matter in which method you are finding it, by using which method you are calculating that. So even though you calculate by using dot product, or let's say you are calculating it by using cross product, final answer for theta, it would be the same. Is that clear?
Yes, sir.
Okay, great. So let's move ahead. very important topic we are going to start. We are going to discuss now. Called as a del operator. This is called as a del operator. So many of you might have seen this symbol, del. This is the del operator, right? So let me tell you, mathematically, this del operator is a kind of partial derivative with respect to x, y, and z. This is for Cartesian coordinate system I'm talking about. If I talk about cylindrical coordinate system, it would be with respect to r, theta, phi. Sorry, r, phi, and z. If I talk about spherical coordinate system, it would be with respect to r, theta, and phi. Right. So we will come to those concepts later on, but for a while, let us define this mathematical operator, which is a del operator for Cartesian coordinate system. And we know that in Cartesian coordinate system, you have the variables x, y, z. Right. So we are going to take a partial derivative, partial differentiation with respect to x, y, z. And that is what called as a del operator. So I'm going to define this del operator now. Del operator, del is equal to, somebody is on mute. Please mute yourself. So del operator, that is del, is equal to dou by dou x a bar x plus dou by dou y a bar y plus dou by dou z a bar z. Right. So this is your del operator. This is the this is the definition of del operator. Right. So if you observe this del operator, what you can tell, what you can say about this del operator? See, this I have written for Cartesian coordinate system. So we are specifically talking about Cartesian coordinate system, or you can say rectangular coordinate. More proper word is rectangular coordinate system. Now just observe this expression and tell me whether it is a vector or a scalar quantity. I'm talking about del operator, whether it is scalar or vector. Can you answer this question? I have written the expression for del operator on the board, whether it is scalar quantity or a vector quantity. Okay, somebody has answered it correctly. It's a vector quantity. It's a vector quantity. It's not a scalar quantity. Reason is because this mathematical expression involves this a bar x, a bar y, and a bar z. And we know that whenever these a bar x, a bar y, and a bar z are involved, that simply means they are indicating the direction. And if any quantity involves the direction, if any quantity is specified with respect to direction, then that quantity is referred as a vector quantity, right? So that's why it is a vector quantity. Keep it in mind, del operator is a vector quantity. Now with respect to this del operator, we are going to talk about three different terminologies. Number one, gradient. Number two, divergence. And number three, curl. I hope you might have heard those terms, those words somewhere, but we are going to study those terms in detail. That's why I'm taking a common picture, like you are going to study gradient, divergence, and the curl, right? So let us start one by one, and let's begin to understand what is gradient. Right, so I'm talking about gradient with respect to del operator only. So let me write here gradient. Right? So what do you mean by gradient? Now let me tell you, when, keep it in mind, when this del operates on a scalar quantity, when this del operates on a scalar quantity, it gives you the gradient. So let me write when del del itself is a vector quantity. When this del, that means a vector quantity, operates on scalar quantity, it is called as gradient. It is called as a gradient. Now, just to understand this, let me take one example of, let's say, a scalar quantity, right? So let's say V is a scalar quantity. Let V is a scalar quantity. In that case, you are trying to find gradient of V. We are trying to find gradient of V, and that is written in short grad V. Grad V, right? And we know that this is also can be written as del V, right? So this del V can be written as del V is equal to, what is the value of del? I have written there. Its value is dou by dou x a bar x plus dou by dou y a bar y plus dou by dou z a bar z, right? So this is the value of del. And what is the value of V? It's not given, it's a scalar quantity, right? So V, right? So this is gradient. So if I simplify this further, del V, that is gradient of V, it is equal to dou V by dou x. So I'm taking taking differentiation of V with respect to x a bar x, plus I'm taking derivative of V with respect to y. So that is dou V by dou y a bar y plus dou V by dou z a bar z, right? So this is your kind of a gradient, right? So this gradient I should highlight here, right? So this is a gradient, and if you observe this gradient, you will find it is, can someone tell me whether it is a vector or scalar? Correct, it's a vector quantity. Now, just to summarize, del operates on a scalar quantity. We call it as a gradient, and gradient always result in a vector quantity. Can you just try to understand this gradient. Gradient means when del operates on a scalar quantity, it is called as a gradient, and this is the end result of gradient. Gradient always results in a vector quantity, right? So that's all about gradient. Now let's proceed further to understand the divergence. I hope you understand what is gradient. Now, while solving the examples, they may give you the value of V. In examination, they may give you the value of V and they may ask you to find out the gradient. So you should know the definition of del. Del is equal to dou by dou x a bar x plus dou by dou y a bar y plus dou by dou y a bar y plus dou by dou z a bar z, right? Yes. Somebody is on mute. Yeah. So curl. Before that, let me take you through a divergence. So divergence is kind of a similar operation. That is, we are using the del operator, right? So when we use this del operator, let me clear the screen first. Yes. Right. So let's understand what is divergence now. I have written two terms here. One is divergence and one is curl. Right. One thing we have already studied, like del, when it operates on a scalar quantity, we will call it as a gradient. When it operates in on a scalar quantity, we will call it as a gradient. But here now we are trying to find the result when this del operates on a vector quantity. But in case of vector, it operates in two ways. One is dot product and another one is cross product, right? So there are two ways when del operates on a vector quantity. So let us understand which are those two ways and how we can identify difference between divergence and the curl, right? So let me write here next heading. It's a divergence. Right. So this is your divergence. Now, similar to the gradient, I will write the definition of divergence also. So when del operates on vector quantity using dot product, we will call it as a divergence. Divergence means when this del operates on vector quantity using a dot product. So in short, if I take kind of, let's say, a vector, let us have a vector, sample vector a bar, right? So a bar will have x, y, z components, right? So ax, a bar x plus ay, a bar y plus az, a bar z, right? So this is the vector. This is the vector that we have. And I want to find the divergence of this vector. So how you can write this divergence of this vector? Either you can write like divergence of a bar, which is equal to div. This is the abbreviation for that. Div a bar, or it is also written as del dot a bar. Del dot a bar. Note down the dot. It's a dot product. I'm going to take a dot product, right? So del dot a bar, del dot a bar. Let's try to find out this del dot a bar. Which is equal to multiplication of those two brackets, means what? In the first bracket, I should write here dou by dou x, a bar x, plus dou by dou y, a bar y, plus dou by dou z, a bar z. This is the value of del. And next value of a bar is, we have assumed the value of a bar as, this is dot product, keep it in mind, ax a bar x plus ay a bar y plus az a bar z. Right. So this is the second term, or you can say the vector that we have assumed. Now, when we try to find out the vector between, the dot product between two vectors, because we know del operator is also a del operator is also a vector quantity, right? Which we have written here. It is a vector quantity. And here also we have taken this as a vector quantity. So we are trying to find the dot product between two vector quantities. So if you go back and if you check the second definition of that dot product, what we have written as a second definition of dot product, can someone recall? A bar dot b bar is equal to just a minute. Share whiteboard, or if the PPT is open, entire screen मतलब कि नाही PPT open पाहिजे त्यावेळेला. Yes. So dot product a bar dot b bar, that second definition we have seen, which was like, can someone recite? It's ax
bx
correct,
plus ay by
ay by
plus az bz.
correct, az bz. Right. So simply if I compare this a bar with del operator and b bar with a bar, you will find we have to take multiplication of those terms only. So dou by dou x ax, dou by dou y ay, and dou by dou z az. Right. So in short, what we can write here is final answer of this divergence of a bar, which is equal to dou by dou x. In the second vector, I should take a bar x plus, ax plus dou by dou y, a bar y, ay, simply ay, and dou by dou z az. Right. So this is the final answer for any divergence. Now, if you compare this, if you observe this, tell me whether it is a scalar quantity or a vector quantity.
So scalar quantity.
It's a scalar quantity, correct. It's a scalar quantity, because if you observe this equation, you will not find any term like a bar x, a bar y on a bar z. Right. So that's why I can say here, this is a scalar quantity. It is a scalar quantity. Now, just to summarize, when del operates on a vector quantity using dot product, it is called as a divergence. And just now we have seen that. Just now we have seen that divergence always results in a scalar quantity. Divergence always results in a scalar quantity. I hope you understood what is divergence. If it is clear, we will proceed further to understand the curl. Right? So let's move on. Let me clear. Okay, I want this. Let it be there only. Okay, right. So I'm going to define now curl. Right. So here I will write the new heading. This is third point I'm discussing with reference to del operator. We have discussed gradient, we have discussed divergence. Now here it is a curl. Curl. And I can write about curl as when del operates on a vector quantity using cross product. You just have to highlight the change. In earlier case, it was dot product. Here I am writing cross product, right? So when del operates on a vector quantity, it is called as a curl, right? So once again, I will take the example of a bar. Once again, I will take vector a bar, which is equal to ax a bar x plus ay a bar y plus az a bar z. And you can say here curl of a bar. Curl of a bar, or you can simply call it as curl a. Curl a bar, which is equal to, you can say del cross a bar. This is your curl, del cross a bar, right? So in that case, del cross a bar, you have to write it as yes. So this is going to be del cross a bar. Del cross a bar. So I should mention the sign here. It is going to be a cross product. And you have to recall the definition. You have to recall the definition of curl. You have to you have to recall the definition of cross product. Second definition of cross product. In determinant, first row a bar x, a bar y, a bar z. Second row ax, ay, az. Third row bx, by, bz. So if you compare that using definition of curl, using definition of cross product, I can write here del cross a bar, del cross a bar is equal to, somebody's mic is so first row as per definition, it has to be a bar x, a bar y, a bar z, right? Second row as per definition, it was in ax, ay, az, right? But here in this case, which are the coefficients that we have? D by dx, d by dy, and d by dz. So this is dou by dou x, dou by dou y, and dou by dou z. So this is the second row. Third row, in that case, it was bx, by, bz. Here in this case, it is ax, ay, az. Right. So I can write here AX, AY, AZ. So this is the final answer for the curl. And if you observe this, whether it is a vector quantity or a scalar quantity,
Vector quantity.
it's a vector quantity. It's a vector quantity, right? So I hope you have noted all those things which I have written on the board, which are very, very important in electromagnetics. This del, gradient, then divergence and curl. Those four things are very, very important. So I expect you have you might have taken a notes of that. Just to recall, I'm going to ask you some of the questions, very easy questions based on that. So since I'm asking the question, you should not leave the class. I want you to little bit talkative. I want you to be interactive, right? So just to encourage that, I want to ask some of the questions, right? So can someone tell me what is gradient? Can someone tell me what is gradient?
So when the del operates on the scalar, then it is known as gradient.
Correct. When del operates on a scalar quantity, it is called as a gradient. Correct. And gradient results in dash dash.
In a
Vector quantity.
Correct. Vector quantity. Gradient results in a vector quantity. Next question, what is divergence?
When del operator of vector using a dot of
Okay. When del operates on a vector quantity using dot product, it is called as a divergence, right? Great. And what is the answer? What is the whether it is a scalar or vector? Divergence results in a scalar or vector?
scalar.
Yes, it
Scalar.
results in a scalar quantity. Great. And what about curl? What about curl?
When del operators of vector quantity using cross product.
Correct. And curl results in
Vector quantity.
great. Very nice. Very nice. Let me take the attendance now. I don't know the roll number of Vaishnavi Walke. Sequence is not maintained for roll number 12 and 21. 12, 21. Okay.
So my
So-
roll number is 31.
Wait. So roll number 1. Roll number 2. Roll number 5. Roll number 10. Roll number 12. Yes, I guess 12 is there. 19. Roll number 19. 23. Roll number 23. 29. Roll number 29. 31. Roll number 31. 32. Yes.
31 is present.
Okay. 32. 33. 36. Yes, those Up to 36 they can leave. 37 is present, 38, 39, 40, roll number 40 is present. 41 is present. Okay.
Present.
Yes. 42, 43, 44, 45, 46, 48, 'okay. Right. So roll number 1 is present because network issue. Okay. ठीक है. Roll number 1 is present. Okay, great. So let us close the meeting now. I guess you have another session to attend. You might have received the instruction from CC. So you are allowed to leave the meeting now.